Good day, everyone. My name is Bianca Desiree Galang, and I am here to discuss the 8 different types of diodes. We are going to discuss the signal. It is a small, nonlinear semiconductor device generally used in electronic circuits, where small currents or high frequencies are involved, such as in radio, televisions, and digital logic circuits. Here is the symbol for signal diodes. Now we are going to discuss the physical construction of a signal diode. Small signal diodes are constructed as PN diodes with a tiny junction area. A smaller junction area gives the diode a smaller junction capacitance. This also reduces the reverse recovery time of the diode to few nanoseconds or less. Small junction capacitance and fast response makes the diode suitable for high-frequency applications. The simplest construction of a signal diode is infusing P-type silicon over N-type silicon. However, simple construction has less predictable specifications. A better construction of a signal diode is the mesodiode. In a mesodiode, a part of the PN block is etched away. This gives the diode a high top lattice structure. Plus, the N-type layer is divided into two regions, one near the P-type material that is slightly doped and another heavily doped layer near the cathode contact. The entire structure is insulated by an encapsulating layer of silicon oxide or passivated glass to protect the diode from oxidation. The mesodiode's construction makes the signal diode more reliable and results in better predictability of its parameters. Now, we are going to discuss the VI characteristics of a signal diode. The diode conducts current when positive supply is applied to the anode and negative supply is applied to the cathode. The diode blocks any current if the voltage is applied in the reverse direction. Ideally, if a signal diode must completely block a negative signal. If the peak of the negative signal is beyond the Zener voltage of the signal diode, it must break and may get permanently damaged. So, a signal diode is expected to work as if perfect one-way valve for high-frequency electronic signals. The positive signal should be higher than the knee voltage of the diode to be visible across the cathode of the diode. Usually, communication and switching circuits operate at signals 4 volts or higher. Therefore, a voltage drop of 0.3 volts for a germanium diode or 0.7 volts for a silicon diode has a negligible impact on the output signal levels. Now we are going to discuss the applications of signal diode. First is clamping and DC restoration. Signal diodes are used for altering the DC level of AC signals. This is called diode clamping or DC restoration. A clampered circuit essentially involves a signal diode and the capacitor. Diode clamping is often used in digital circuits to reset upper and lower limits of the square wave signals to either communicate signals between two systems of different signal levels. Next is protection diodes. Signal diodes are also used to protect other semiconductor devices and interfaces from sudden voltage spikes and excessive signal voltages. Next is wave shaping or clipping. Signal diodes are frequently used for clipping AC signals. One or more signal diodes can be used to clip an input signal. One signal diode can clip either only a positive cycle or only a negative cycle. Last we have voltage regulation. In some cases, signal diodes can also be employed for simple voltage regulation. In forward bias region, a signal diode has a constant voltage drop across it. And those are the applications of signal diodes. Next, we are going to discuss the power. A diode that has two terminals like anode and cathode and two layers like P and N used in the power electronic circuit is known as power diode. This diode is more complex in construction as well as in operation because low power device has to change to make them appropriate in power applications. This is the symbol for power diode. In the physical construction, the construction of this diode includes three layers, like the P plus layer, the N layer, and the N plus layer. Here, the top layer is the P plus layer, it is heavily doped. The middle layer and negative layer, it is highly doped. And the last layer and positive layer, and it is heavily doped. Here, P plus layers acts as an anode, and the N plus layers acts like a cathode, and the N negative layer acts as a middle layer or drift layer. For the VI characteristics, in signal diodes, for forward, a bias region, the current increases exponentially. However, in power diodes, high forward current leads to high ohmic drop which dominates the exponential growth, and the curve increases almost linearly. The maximum reverse voltage that the diode can withstand is depicted by VRRM. Example is peak reverse repetitive voltage. Above this voltage, the reverse current becomes very high abruptly, and as the diode is not designed to dissipate such a high amount of heat, it may get destroyed. This voltage may also be called peak inverse voltage or PIV. Here are some applications of the power diode. First is, this diode provides uncontrolled power rectification. These are used like snubber networks and freewheeling diodes due to their characteristics like voltage and high current. These diodes are used in several applications like DC power supply, for charging the battery, inverters, and AC rectifiers. Lastly, these diodes are used as feedback, freewheeling diodes, and high voltage rectifier. Now, let's move on to the Schottky diode. Now, we have the Schottky diode. It is a metal semiconductor junction diode that has less forward voltage drop than the PN junction diode and can be used in high-speed switching applications. And this is the symbol for Schottky diode. Construction, it is a unilateral junction. A metal semiconductor junction is formed at one end and another metal semiconductor contact is formed at the other end. It is an ideal ohmic bidirectional contact with no potential existing between the metal and the semiconductor, and it is non-rectifying. The built-in potential across the open-circuited Schottky barrier diode characterizes the Schottky diode. Characteristics: the forward voltage drop of the Schottky barrier diode is very low compared to a normal PN junction diode. The forward voltage drop ranges from 0.3 volts to 0.5 volts. The forward voltage drop of the Schottky barrier is made up of silicon. The forward voltage drop increases at the same time increasing the doping concentration of N-type semiconductor. The VI characteristics of a Schottky diode are very steeper compared to the VI characteristics of normal PN junction diodes due to the high concentration of the current carriers. Here are the applications of the Schottky diode. First is, it is used in a general purpose rectifiers. It is also used in radio frequency applications. Widely used in power supplies, used to detect signals, and lastly, it is used in logic circuits. Now, we are going to discuss the LED or the light emitting diode. Light-emitting diodes, commonly known or called as LEDs, are real unsung heroes in the electronics world. They do many different jobs in all kinds of devices. They form numbers on digital clocks, transmit information from remote controls, light up watches, and tell you when your appliances are turned on. Collected together, they can form images on a jumbo television screen or illuminate a traffic light. The LED, as it is, or mostly called as light-emitting diode, is basically just a specialist type of diode, as they have a very similar electrical characteristics to a PN junction diode. This means that an LED will pass in its forward direction, but block the flow of current in the reverse direction. And as we can see, here is the symbol for the LED. For the physical construction, one of the methods used to construct LED is to deposit three semiconductor layers on the substrate. The three semiconductor layers deposited on the substrates are N-type, P-type, and the active region. Active region is present between the N-type and P-type semiconductor layers. When LED is forward biased, free electrons from N-type semiconductors and holes from P-type semiconductors are pushed towards the active region. When free electrons from the N side and holes from P side recombine with the opposite charge carriers in active region, an invisible or visible light is emitted. For the operation or VI characteristics, a thing is to be kept in mind while connecting LED to the power supply, which is that a resistor is to be placed in series with the whole circuit. This is done so as to secure the circuit from excess current. Usually, during operation, low DC voltage is provided to the LED and around 5 milliamperes of current is to be provided to it. This is maintained by limiting the resistor. As we can see, the x-axis represents the forward voltage, applied voltage, and the y-axis shows the forward current flowing to the device. For the applications, it can be used in burglar alarm systems, calculators, picture phones, traffic signals, digital computers, multimeters, microprocessors, digital watches, automotive heat lamps, camera flashes, and even in aviation lighting. Next we have is the laser diode. A laser diode is a semiconductor device similar to a light-emitting diode or LED. It uses a PN junction to emit coherent light in which all the waves are at the same frequency and phase. This coherent light is produced by the laser diode using a process termed as light amplification by stimulated emission of radiation, which is abbreviated as laser. And since a PN junction is used to produce laser light, this device is named as a laser diode. Before we learn more about the working process of a diode, here is the symbol for the laser diode. The input terminals are connected to a metal plates which are sandwiched to the N-type and P-type layers. This type of laser diode is also called as the homojunction laser diode. The intrinsic region between the P-type and the N-type material is used to increase the volume of active region, so that more numbers of holes and electrons can accumulate at the junction. This allows more number of electrons to recombine with holes at any instant of time, resulting in a better output power. The laser light is emitted from the elliptical region. This beam from the laser diode can be further focused using an optical lens. This entire PIN diode, or the P-type intrinsic N-type arrangement, is enclosed normally in a metal casing. For the VI characteristics, in general, the laser diode's forward voltage is about 1.5 volts, and the forward voltage is affected by the operating temperature. From the diagram, it can be seen that the voltage across the laser diode is typically around 1.5 volts. Although it is necessary to check for the particular laser diode in question, the forward voltage specification will vary according to the materials used in the diode, current, etc. Although the forward voltage does vary with temperature, this is not normally a major consideration. There are several applications for the laser diode. First is consumer electronics. CD, DVD players, laser printers, fiber optic communications, barcode readers are examples for this. Next is medical machines. Laser diodes are used in machines used to remove unwanted tissues, eliminating cancer cells, non-invasive, and even in cataract surgeries. We also have autonomous vehicles. Laser diode technology is used in making LiDAR systems implemented for autonomous driving. For scientific instrumentation, lasers are used in devices used for remote contactless measurements, spectrometry, rangefinders, and many more. For industrial applications, laser diodes are used as a source of high-intensity laser beam for precise cutting of materials. They are also used in 3D printing to soften the substrate. Next, we are going to discuss the photodiodes. It is a form of light sensor that converts light energy into electrical energy. Photodiode is a type of semiconducting device with p-n junction between the positive and negative layers. An intrinsic layer is also present. The photodiode accepts light energy as input to generate electric current. It is also called as photodetector, photosensor, or light detector. Photodiode operates in reverse bias conditions. Example is the P side of the photodiode is connected with negative terminal of the battery or the power supply, and the N side to the positive terminal of the battery. For the physical construction, the photodiode is made up of layers of P-type and N-type semiconductor. In this, the P-type material is formed from diffusion of the lightly doped P-type substrate. Thus, the layer of positive ions is formed due to the diffusion process, and N-type epitaxial layer is grown on N-type substrate. The P plus diffusion layer is developed on N-type heavily doped epitaxial layer. The contacts are made of metal to form two terminals, cathode and anode. The front area of the diode is divided into two types that are active surface and non-active surface. The non-active surface is made up of silicon dioxide, and the active surface is coated with anti-reflection material. The active surface is called so because the light rays are incident on it, while on the non-active surface, the light rays do not strike. The active layer is coated with the anti-reflection material so that the light energy is not lost and the maximum of it can be converted into current. The entire unit has a dimension of the order of 2.5 mm. For the VI characteristics, photodiodes operates in reverse bias condition. Reverse voltages are plotted along x-axis in volts and reverse currents are plotted along y-axis in microampere. Reverse current does not depend on reverse voltage. When there is no light illumination, reverse current will be almost zero. The minimum amount of current present is called the dark current. When the light illumination increases, reverse current also increases linearly. For the applications, photodiodes are used in many simple day-to-day applications. The reason for their use is the linear response of photodiode is to light illumination. When more amount of light falls on the sensor, it produces high amount of current. The increase in current will be displayed on a galvanometer connected to the circuit. It will help to provide an electric isolation with the help of optocouplers. It can also be used in safety electronics like fire and smoke detectors. When utilized in cameras, they also act as photosensors. And lastly, they are used in numerous medical applications like instruments to analyze samples, detectors for computed tomography, and used in blood gas monitors. We also have the PIN diode. The PIN diode is one type of photodetector used to convert optical signals into an electric signal. The PIN region comprises of three regions like the P region, I region, and the N region. A PIN diode is a special type of diode that contains an undoped intrinsic semiconductor between the P-type and the N-type semiconductor regions. It differs from a normal diode in the sense that it has an extra layer in between the P and the N junctions. By an intrinsic layer, we mean a pure crystal of silicon or germanium without any doping in it. This layer does not conduct electric current as well. The P-type and the N-type layer is heavily doped as they are used for ohmic contacts. For the physical construction, a PIN diode is a three-layer device composed of P region, N region, and intrinsic region. P region is formed by doping trivalent impurity to the semiconductor, and the N region is formed when the pentavalent impurity is doped to the semiconductor material. The region of an intrinsic semiconductor is nothing but the undoped semiconductor material. For the VI characteristics, the forward resistance characteristic and the reverse capacitance characteristics are shown graphically in below figure for a typical PIN diode. The PIN diode is used as a DC-controlled microwave switch operated by rapid changes in bias or as a modulating device that takes advantage of the variable forward resistance characteristic. Since no rectification occurs in the PN junction, a high-frequency signal can be modulated by a lower-frequency bias variation. A PIN diode can also be used in attenuator applications because its resistance can be controlled by the amount of current. Certain types of PIN diodes are used as photodetectors in fabric or fiber optic systems. For the applications, the PIN diode is used as high voltage rectifier. The intrinsic layer in the diode offers a partition between both the layers, permitting higher reverse voltages to be tolerated. The PIN diode is used for an ideal radio frequency switch. The intrinsic layer among the P and N layers increases the spaces between them. This also reduces the capacitance between the regions, thus raising the level of isolation when the PIN diode is reverse biased. The PIN diode is also used as a photodetector to convert the light into the current which takes place in the depletion layer of a photodiode. Rising the depletion layer by inserting the intrinsic layer progresses the performance. Lastly, it gives electronic switching. This diode is ideal in electronic switching applications for electronics. It is mainly useful for RF design applications and also for providing the switching or attenuating element in the RF. The last diode that we are going to discuss is the Zener diode. A Zener diode is a special type of device designed to operate in the Zener breakdown region. Zener diodes act like normal PN junction diodes under forward bias condition. When forward biased voltage is applied to the Zener diode, it allows large amount of electric current and blocks only a small amount of electric current. For the physical construction, here, N and P substrates are diffused together. The junction region is covered with a layer of silicon oxide at the same time during construction. The whole assembly is metallized in order to generate anode and cathode connection. The layer of silicon oxide helps to prevent contamination of the junctions, thus is used in the construction of Zener diode. For the VI characteristic, the figure represents the curve for both silicon and germanium diodes. The forward characteristic of the Zener diode is similar to a normal diode, which is clearly seen in the figure above. In reverse bias condition, a small reverse current flows due to minority charge carriers. On increasing the reverse voltage, current increases. A point is reached when the junction gets destroyed and a sharp increase in current is noticed without any noticeable increase in reverse potential. This voltage is known as the Zener voltage. The current through the device is limited by making use of external resistance. Lastly, for applications, it can be used in voltage regulation. Regulating the voltage of a circuit is its ability to keep the output voltage fixed regardless of the variation of the input or load current. Next is, it can be used in switching operation. A Zener diode can be used for switching purposes because it shows an abrupt transition from low to high current. Next is meter protection. A Zener diode can protect a meter from the excessive voltage applied to it. Next is clipping circuits. Zener finds its application in the clipping circuit where the peak of the applied input is clipped off. Again, my name is Bianca Desiree Galang, and thank you for listening on my discussion on the 8 different types of diodes.